in this question here, we're given a right angle triangle and we want to determine 4 trig ratios, 2 of them which are familiar and the other 2 which are inverse. Let's take a look. So here's our triangle. You'll notice that one of the sides is missing, and I could fill it in right now, and maybe I will. Okay, let's just call this x here and use our trusted Pythagorean theorem. And we know that's equal to 10 squared. Okay, again, just the sum of the square of the sides is equal to the square of the hypotenuse. And if I start solving this, I'm going to do a few steps at once. I'll notice that x squared is going to be 36, or I can just say x equals 6. Again, I disregard the negative value because in this case we can't have negative lengths. So let me just circle that, pop it up there, and I can now replace the x with a value of 6. So sine of theta. So we know that theta is our reference angle, and the sine of it is going to be the opposite over the hypotenuse. So notice that it's asking me for sine theta, not the value of theta, but the value of the ratio of its opposite and hypotenuse. So I'm going to write sine theta equals 8 over 10. And if I reduce that, I get 4 over 5. Great. What about cosine theta? Well, cosine theta is just the adjacent over the hypotenuse, or 6 over 10, and that gives me reduced 3 over 5. And finally we have, now we have the reciprocal ones, secant theta, which is just 1 over cos theta, or we can write that as 5 over 3. And now finally we have cotangent theta, that's 1 over tangent theta, which is going to be, let's figure out what tangent is first. So tan theta is equal to opposite over adjacent, or 8 over 6, which becomes 4 over 3, which means that the reciprocal of that is going to give me 3 over 4. And there you have the values of sine, cosine, secant, and cotangent with respect to these measurements here.